Now I have to describe software models. First of all, waterfall models. In a strict waterfall model, after each phase is finished, it proceeds to the next one. Reviews may occur before moving to the next phase, which allows for the possibility of changes which may involve a formal change control process. Reviews may also be employed to ensure that the phase is indeed complete. The phase completion criteria are often referred to as a gate that the project must pass through to move to the next phase. It is the first model developed which is more authentic and reliable. Requirements are analyzed and documented on details and then freezed. It cannot be reworked to the first step or to the last step. Developers are also involved after the later stage. Customers are usually not involved after the requirements gathering. Customers are sometimes unsure about the development of this software. This is a flowchart of waterfall models in which first of all we get requirements, then we design the software, then implementation occurs, and then verification. After the verification, we perform the maintenance. Okay. Now, spiral model. What is spiral model? The key characteristics of a spiral model is risk management at regular stages in the development cycle. In 1988, Baum's published a formal software system development spiral model, which combines some key aspects of the waterfall model and rapid prototyping methodologies, but provided emphasis in a key area many left had been neglected by other methodologies. It is made by Baum, also known as Baum's spiral model. There, the technical risks are very high. In spiral model, there is a special phase for risk analysis, and in it we can also use the object-oriented technology. This model is relatively new and is best for the project developments. In software spiral models, we have communication, planning, and risk analysis. Risk analysis is a separate stage in this model. Communication, planning, risk analysis, engineering, construction, and release, and then we develop the software or we give this software to the customers. Now, win-win spiral models. The win-win spiral model uses three win-win to the develop software and system requirements and architectural solution has been condition negotiated among a project's stakeholders. The win-win negotiation tools is a Unix workstation-based groupware support system that allows stakeholders to win conditions, explore the interaction, and negotiate mutually agreements on the specifics of the new project being contracted. Win-win spiral model actually depends on the stakeholders. The stakeholders may be primary or secondary. Now, it also involves customer, clients, software team, sponsors, partners, and program managers. In this software, you have to satisfy the stakeholders, not only the customers. First of all, you have to identify the stakeholders. Then you have to define the win-win condition, and then you have to reconcile the win-win condition. After that, you have to define constraint, resources, and resolve risk. Define products and processes and alternatives. Then you have to define next level product and processes. Customer feedbacks are involved at the later stage. This is a flowchart of win-win spiral model. These all things that I have described previously is involved in this flowchart. You can see that. Now, component assembly. What is component assembly? Component assembly, it is used in the combination with spiral model. About 70% time and cost can be saved to this assembly. Object-oriented technology can also be used in it. C++ and Java are more appropriate. Here work is done already. You have to just assemble different components for the modification. This is a flowchart of component assembly. First of all, we have to identify the required components. We have to look the components into the library. Then, if we have the components in the library, we have to extract the components. If we don't have the components, we have to put the components into the library for the development. And after that, at the last stage, we have to develop integration of the components for modification, for construction, and for engineering. Now, forward method model. In computer science and software engineering, forward methods are a particular kind of mathematically based techniques for the specification, development, and verification of software and hardware system. The use of forward methods for software and hardware design is motivated by the expectation that, as in other engineering disciplines, performing appropriate mathematical analysis can contribute to the reliability and non-design of a design. Forward method model is based on algebraic and arithmetic notation. It is used to develop customer requirements at uniform and constant level. Forward engineering and reverse engineering concepts are also used. In forward engineering, we can just link with the last stage directly from the first stage in forward engineering, while in reverse engineering, we just link from the last level to the first level directly. For forward and reverse engineering, we use some tools, just like rational rows, ERT data model, DAG, Oracle, MS, SQL. For this model, we need some mathematical expertise also. This is a flowchart of formal method model, in which we gather requirements, then analysis and model, and then design and testing a program. Thank you so much.